Hello, my name is Keshwani. S-K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math questions out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase it immediately. You're going to need it. There is no such thing as a preparation for GRE without this official guide. This is the only source on the market which will provide you with the real exam, real questions. Anyway, enough of that. The problem that I'm about to solve is the one that you will find on page number 240. Page 240, and today is our lesson number 129. Lesson number 129. I'm not going to change this part, geometry for GRE day 40. I'm going to keep that same for the both videos because it's a continuation from yesterday. I'm going to use the same tag. Anyway, here's what's going on. We are given two functions. We are given these two functions, and we are asked to find the point of intersection of these two functions, which is what we did yesterday. We found the point of intersection of these two functions graphically. Because that's the second part of the question. The question says find the points, but find the precise point, and then it goes on to say show these points on a graph, which we did yesterday. These were the 2 points. This is where this is what the graph looks like for this linear equation, and this is what the graph looks like for this equation, which is a parabola, and this is where they intersect. And we found out that the point of intersections are right here, precisely here. How? Well, by cheating. We looked at the answers. We looked at the answers on the top of page number 241, and right there are the point of intersection on the top of page 241. They give you the y coordinates of the point of intersection of P and Q, and at the very bottom of page number 240, they give you the points of x coordinates of the points of intersection of P and Q. So we cheated. Today we're going to do the actual work. Okay, let's start. So the places where they intersect each other, the x coordinate and the y coordinate of this point, the x coordinate and the y coordinate of the point of this point, the blue point that belongs to this line here, straight line, has the exact same coordinates, x and y coordinates, as the one that belongs to this graph. That's why it's called point of intersection. That's where the x and the y coordinates of the two graphs equal each other, because that's what it means to intersect. So we're going to set this y equals that y, we're going to set them equal to each other and solve for x. So let's do that. So we do so, points of intersection, we do so by setting, we find the points of intersections by setting the two equations equal to each other. So let's do that. The first equation is this, negative 1/2 x plus 1 equals x squared. I want to get rid of this 2 from the bottom. I find it very annoying. Let's multiply both sides of the equation. Let's multiply both sides of the equation by 2. When you multiply both sides of the equation by 2, now 2 times negative half is how much? Well, I know 2 times half is 1, or in other words, 2 halves make 1. Of course, if you have 2 halves, put them together, you get a whole pizza. Half a pizza and half a pizza, 2 halves make a 1. So 2 halves, 2 times half is 1, therefore 2 times negative half would be negative 1. Negative 1x, and then 2 times 1 is simply just 2, and then here we get 2x squared. Let's write this equation in what is known as the standard quadratic equation. Standard form of a quadratic equation is what I meant to say. The standard form of the quadratic equation dictates that we write these exponents in descending order. The first term, this is called a term, the first term must be the one with the highest exponents, then the next one, and then the constant. So let's bring this x over here. Let's add x to both sides, and let's subtract 2 from both sides. And by the time we do so, deposit negative x, negative 1x, and a positive 1x, they cancel each other out. Positive 2 and a negative 2, they cancel each other out. That was the point. So here we end up with a big fat 0. Yep, a big fat one, not a regular one. And the equation that we get is 2x squared plus x minus 2. Let's put this equation on the very top. I'm going to erase everything because we're done. We don't need any of this stuff now. This is what is known as a quadratic equation in standard form. In other words, we could have written the same exact equation as 2x squared plus x equals positive 2. This is still the same exact equation. We have just taken a 2 to the other side, but this is no longer in the standard form. We could have also written the equation as x minus 2 equals negative 2x squared, as it was before. This is not in the standard form. Standard form means exactly what I just described before, that we have to start with the highest exponents first, then the next exponent, and then the constant. Why the constant at the end? 2x squared plus x minus 2 times 0. Let's digress for a second. Of course, when we put down just x here, what exponent does this have? This has an exponent 1. What exponent does this have? It's just negative 2. Why did I put x here? Why the hell did I put x next along with negative 2? What exponents could I possibly put here to make it negative 2? It has an exponent of 0. Any number raised to a 0 power equals 1. Any number in the world at all. Negative 17, negative 7 raised to 0 is 1, negative 37 raised to 0 is 1, 3/4 raised to 0 is 1, 1 million raised to 0 is 1. Any number raised to 0 equals 1. All of these quantities, 1 million raised to a 0 power, 3/4 raised to a 0 power, 37 raised to a 0 power, negative 7 raised to a 0 power, that's a 0, not a 6. 0 power equals 1. So that's what that is. This is actually a 1. This 2 times 1, 2 times 1, there you go, that's your negative 2. This negative 2 is same as 2 times 1, and 1 can be written as x raised to 0. So there you go, this is what I was talking about. The powers have to be in descending order. 2, 1, 0. You see, even though x does not actually show up there, but it's there. It's there. Right there, x raised to 0, it is there. For those of you who remember from a long time ago, I don't know why it's coming to my mind for no good reason at all. It's like a ragu spaghetti sauce. It's all in there. Don't ask me what that means for those of you who are watching this thing outside the country, okay? And even inside the country, most of you would not know it. It's there. Even though we do not say it, that 2 is same as negative 2. See, 2, negative 2 is same as 2 raised, negative 2 raised times x raised to 0. 5 can be written as, I can put down any variable, it doesn't matter, any number. I can put down p raised to 0. That's still a 5. Even though it doesn't matter what the value of p is. Any number raised to 0 is 1. So 5 times 1 is 5. You see? That's it. We're done with this part. There was a small digression. I don't know why I did that. That was a standard form. Now we have to solve it. To solve a quadratic formula, here's what we're looking for. We're looking for two numbers which, when multiplied, together give us a product of 2 and a negative 2, product of 2 times negative 2 or negative 4. That's the first condition. We're looking for two numbers whose product has to be negative 4. Because those are the two exponents. You look at the exponents of the x squared, you look at the constant here, and you multiply them together, and whatever it comes out to be, that's what these two numbers have to multiply out to be. We're looking for two numbers which, when multiplied together, give us a product of negative 4. And that's the second condition, that's the first condition. And they have to add up to this right here, the coefficient of the middle term. The coefficient of the middle term here is just 1, it's positive 1. They have to add up to positive 1. That's it. Our job now is to think of these two numbers. You have to think of it. It's just, they don't come from anywhere. There is no there is no trick to it. For example, if I ask you, can you give me the product of two numbers? Okay. For example, if I ask you, what's the product of two numbers, let me start again. If I ask you, can you give me two numbers such that when I multiply, let's change them. Let's do it right here. Let's keep it simple here. I'm going to put them in the red pen and then we'll erase them, okay? Can you give me two numbers which when multiplied together give us a product of 10, and when we add them together we get 7? Well, that's very easy. That's very simple. Though the two numbers are 5 and 2. 5 times 2 is going to give us a product of 10, and 5 plus 2 is going to give us a sum of 7. That was very simple. This, on the other hand, is not. This one will require some thinking. This, on the other hand, is not. I'm going to say it one more time, and then I want you to pause the video. If you want to learn algebra properly, there is a difference between simply going to some place, going to some prep course, and asking them to teach you some prep course and magically it's going to raise your score. It's not just going to magically raise your score. You have to know the material. You have to understand it. You have to master it. I want you to learn the math, not simply for the sake of taking the freaking GRE or GMAT or HESI or whatever it is. I want you to learn the algebra, the concept behind it. You understand? I want you to own it. So, here's what we're looking for. We're looking for two numbers which, when multiplied by together, give us a product of negative 4. And when you add them, they have to add up to 1. What I want you to do now is to pause the video. I want you to literally pause the video for however long it takes, whether it takes 1 minute or 2 hours or until tomorrow. Pause the video and think about it. Once you have your answer, I want you to resume the video. So here's the deal. In order to master this concept, this method is called, this method is what is known as factorization. Factorization. In order to learn this concept, in order to understand this method, for those of you who are struggling, I want you to watch these videos. Go type in revise GRE math. I spent 5 days on this concept. Day 99, 100, 101, 102, 103. I spent 5 full days dealing with this concept of factorization. If you're shaking on this concept, stay. Of course, if you master it, then of course there is no need for you to even watch this video. I don't know why you would be watching it, because this is for the benefit of those people who want to learn factorization. Watch these videos, these 5 videos, 99 through 103, master it, and then in the future, hopefully you'll be able to tackle it. So what's the answer here? What are the two numbers? For example here, we need a negative 4. Negative 4 is what we need here. Well, when you need negative 4, there aren't too many options. If the product is negative 4, it's got to be either positive 1 times negative 4. Positive 1 times negative 4 gives you a product of negative 4. Or it's got to be negative 1 times positive 4. That gives you negative 1 times positive 4 gives you a product of negative 4. Or it's got to be positive 2 times negative 2. That's it. There are no other options. There are no other options. Now what happens when we take their sum? when we take their sum, what happens? The sum of positive 1 and a negative 4, sum of positive 1 and a negative 4 is negative 3. We want the sum to be positive 1. Sum of negative 1 and a positive 4 is positive 3. That's no good. We want the sum to be positive 1. Sum of a positive 2 and a negative 2 is a big fat 0. So what are the two numbers that we're looking for here? Well, you're going to hate me for it. You're going to hate me for what I'm about to say. I need the room, so I'm going to erase a lot of this stuff here so that I can write down the punchline. Here's the punchline. What are the two numbers? The answer is no such two numbers exist. Alas, no such two numbers exist. There are no whole numbers factors of this equation. The only way we can ascertain, we can figure out, we can establish, we can determine the values of x which will satisfy this quadratic equation is through employing what is known as a quadratic formula. And quadratic formula we must use. And that is also something you have to know for the exam by heart. Even though I myself hate using quadratic formulas because I hate memorizing things. But once in a while one has no choice. And we are unfortunately in one of those situations. So let's go to the formula. But no such number exists. As you can see here, this is it. We have exhausted all the possibilities. There are only three possibilities for the product of two integers to be negative 4. In order for the product of two integers to be negative 4, it's either going to be negative 4 times positive 1, or positive 1 times negative 4, or positive 2 times negative 2. And in none of these three scenarios you will find a sum of positive 1. As you can see right here clearly, the sum happens to be negative 3, positive 3 and 0. We're looking for positive 1. It doesn't exist. No such numbers exist. I'm sorry. Let's erase it. We have to use, we have no choice. We have to use quadratic formula, which goes something like this. The quadratic formula tells you that x equals negative b plus or minus b squared minus 4ac over 2a. Now what are these a, b and c business? I left no room, did I? So I have to erase this part here. No, here are your a's and b's and c's. This a that we're talking about, a times c, this a is the coefficient of the x squared. This is your a. The b that we're talking about is the coefficient of the x, which is your b. And your c that we're talking about is this guy right here. So in this case, in our case, b equals positive 1. So negative times positive 1 plus or minus b squared, which is positive 1. Positive 1 squared. The reason I always make a point of putting down a sign in front of it, even though it's positive, I don't have to put down positive 1 squared. I could have just as well put down 1 squared, because this is where you end up making careless mistakes. When you're dealing with quadratic formula, pay very close attention to the sign of the coefficient, because if you mess those up, of course you're going to get the wrong answer. Minus 4 times a, which is positive 1, times c, which is negative 2, you see? Negative 2. Now something does not seem right. That is not what they have here, is it? They've got 17 in the parentheses, and so do I here. B squared, which is 1. I'm trying to figure out where I made a mistake. Minus 4ac, 4. Ah, a is 2. What the hell? A is not positive 1. A is 2. A is positive 2. Not a B is a positive 1. See, I wasn't paying attention. Right here, it says right here, A equals positive 2. Because I just realized that I wasn't getting what they show in the book. Over 2 times A, which is 2 times 2. Well, let's continue this on the top, because we need the room. I'm going to erase all of this now. This is your x. X equals positive 1 or negative 1. Oh, sorry, x equals negative times positive is negative, plus or minus 1 squared is just 1. Negative 4 times positive 2 times negative 2, which is what this part is. Positive 2 and a negative 2 give us negative 4, and negative 4 times negative 4 is a positive 16, which is where they're getting 17, over 2 times 2, which is 4. Now, we can quickly approximate the answer. So I'm going to approximate the answer quickly, okay? So which means x is approximately equal to negative 1 plus or minus, you see, square root of 16. Square root of 16 is 4. This is square root of 17, which means it is slightly more than 4. I'm going to pretend that it is 16, which is hence the change. You see here it says equal to, and here it says approximately equal to, because I'm going to pretend that it is 16. X is approximately equal to, which means x is approximately equal to negative 1 plus a 4 over 4. Negative 1 plus a positive 1 is 3. So it's 3/4, positive 3/4 approximately, which we know is not true. In reality, it's not positive 3/4, which is 0.75. The exact answer is 0.78. Right there, 0.78. Similarly, x is also approximately equal to negative 1, and now we take the negative root. We use the positive 4, now we take the negative 4. Negative 4 over 4, which gives us negative 5 over 4. Negative 5 over 4 is same as negative 1 and a quarter. Negative 1 and a quarter, of course, is same as negative 1.25. Notice how it went. Here I use the symbol for approximately equal to. X approximately equals to this guy. But this guy does not approximately equal to this guy. This guy is this guy. Hence the equal sign. Negative 1 minus a 4 equals negative 5 over 4 equals to, not approximately equals to. And negative 5 over 4 is exactly equal to negative 1/4, which is exactly equal to negative 1.25, which means x is approximately equal to negative 1/4. But of course we know the real answer. It is exactly equal to negative 1.28. So if I had the calculator, I would have done it out. I would have done the precise measurement. I don't have the calculator with me right now, alas. So that's it. Now our job is to find the y value. So let's do that here. Y is going to be approximately equal to. Now why do I say approximately? Because since the value of x is approximate, and we're going to use the approximate value of x, therefore the y that we're going to generate is also going to be approximate. Now in order to find out the values of y, we have two choices. We can use either the equation for the linear function, which is negative half x plus 1. We put in y equals negative half x plus 1. I can plug in the values of x from here in this thing, or we can put it in a second graph, which is x squared. I prefer to do the second one because I don't like this mumbo jumbo of negative half business. So I'm going to use the second equation. In other words, I'm using the equation of the parabola to find the values of y. Okay? Let's do it, shall we? See what happens. Y equals to x squared, and therefore y approximately equals to, this symbol means therefore. For those of you who still do not know it, if you've been watching my videos on a regular basis, you know by now, this is a standard symbol which means therefore. Therefore, y equals 3/4 squared, approximately, which is same as 9 over 16. What do they have? 9 over 16 is what I'm getting. What does they have value for y? Now, 9 over 16, listen carefully. 9 over 16, I know that 8 over 16 is half. So it's a little bit more than half. This value is a little bit more than half. It's a little bit more than half. 0.5 plus. It's half and a 1/16. And the precise answer that you see on the top of the page there is 0.61. This turns out to be 0.61. The exact value is 0.61 right here. Now let's do the next one. Y is approximately equal to, now we're going to use this one, 5/4, negative 5/4. Negative 5/4 squared. First thing we notice is that since it's negative, even though it's negative 5, when we square it, it's going to disappear. It's going to be 25 over 16. Again, that's the approximate value of y. 16 over 16 is exactly 1. Listen carefully. 16 over 16, see, 25 over 16 is same as 16 over 16 plus a 9 over 16. 16 over 16 is 1. 9 over 16 is slightly more than half. So this is going to be slightly more than 1.5. Slightly more than 1.5. And if you look at the top of the page there, it tells you that it is in fact 1.64. 1.64. Wow, that's it. We are done. We are done with this video. It was a very long video. And if you had the patience to come through with me in the journey this far, then kudos to you. I hope you got something out of it. I will see you tomorrow on day number 130. Bye now.